everyone, we're doing a worksheet on factors and multiples. So you can find the worksheet in the description, link to the worksheet. Alright, so let's jump on to the first few questions. Question number 1, complete the list of factors of 36. So factors are the numbers that completely divide 36. So we can already see that 1 is a factor of 36 because 1 completely divides 36, of course, and 136 are 36, so we've written 36 over here as well. Okay, then 2 also completely divides 36, and 2 18s are 36, so 18 is also a factor of 36. Then 3 divides 36 and 3 12s are 36, so 12 is also a factor of 36. And then 6 can completely divide 36 without leaving a remainder, and 6 6 are 36. And then what else? I skipped 4. 4 is also a factor of 36, and 4 9s are 36, so 9 is also a factor of 36. 9 also completely divides 36 without leaving a remainder. So these are the answers for question 1. Okay, question 2 is part A. 1 and 12 are factors of 12. Write down all other factors of 12. So for 2A, the other factors would be 2 divides 12 and 2 6 are 12, so 6 is also a factor. 3 divides 12 and 3 4s are 12, so these are the factors of 12. Part B, write down the multiples of 9 between 20 and 40. So multiples are the numbers that come in the table of 9. So we have 18 in the table of 9, but it's not in the range of 20 and 40. So then we have 27 in this range. 27 comes in the table of 9, and also 36. So these two are the answer for 2B. Question 3, find two prime factors of 323. So you can grab your calculators and simply start dividing the prime numbers with 323. You will 2 is the first prime number, so you'll notice that you're not getting a whole number. Then you'll try 3 is also a prime number, then you'll try 5, and so on. You'll notice that in fact, we don't need to try 2 and 5 because we know that this number is not divisible by 2 and 5. In fact, it's not divisible by 3 either, because 3 plus 2 plus 3 is 8, and 8 is not divisible by 3. So the whole number 323 is not divisible by 3. Then you can check for 7 in this way, and you can check for 11, and so on, and you'll notice that this number 323 is completely divided by the prime number 17, and the answer would be 19. So the two prime factors of the number 323 would be 17 and 19. So the answer would be 17 and 19. Part 4, write 2016 as product of prime factors. So for that, I'll simply start dividing this. Let's start with 2. So in fact, I think I need to clear space. Okay, so let's do part 4 here. So we have to factorize this using prime numbers. So let's start with 2 1 0 0 8. Then again use 2, so 5 0 4. Then again use 2 2 2. This becomes 10, so 5s are and 2s are. Then again 2 2 1s are, 2 2s are 4, and 126. And then again 2 and 63. Now we can't divide with 2 anymore, so let's take 3 3 2s are 1s are, and 3 sevens are, and then 7 ones are. Now we have to write this in a proper form. So we have 5 twos times uh, 2 threes and times 7. So we write 2 power 5 times 3 square times 7, which is the answer for part question 4. Okay, so the next subtopic is square root and cube root using prime factorization. So I haven't seen any such questions in the IGCSE past papers, but these are very common questions in GCE past papers. So I thought of just introducing these such questions in the worksheet, so that just in case we're ready if we get a question like this in our exam as well. Alright, so we're given, let's do one. Okay, so we're given 324 is 2 power square times 3 power 4, and next we have to find under root of 324. So what we need to do now is simply just divide these powers with 2. So we get 2 power 1 times 3 power 2, so we get 9 times 2, which is 18. So under root of 324 is simply 18, and if you get a question like this in the exam, it will clearly say without using a calculator. So make sure you're simply not pressing under root 324 in your calculator and getting 18, because it says hence. Hence means you're bound to use these factorized form. Alright, so question 2 is pretty much the same. Let's do question 3, where we have to find the cube root of 5832. Now again, what we'll do is that we'll simply divide these powers with 3 now. So we get 2 power 1 times 3 power 2. So again we get 9 times 2, 18. So cube root of 5832 is also 18. Now let's do question 5, because it's a little different. Okay, so for question 5, okay, we're given 1800 in the form of prime factors, and we are supposed to write under root 1800 in this form, p under root q. So let's find under root of 1800 first. Under root means simply divide the powers with 2. We can't divide 3 with 2. We can divide this 2 with 2, and then we can divide this 2 with 2. So a better approach of doing this is, let's write 1800 in this form, 2 times 2 times 2 times 3 times 3 times 5 times 5. Now when we're taking square roots, we write the numbers occurring twice once. So 3 square becomes, under root 3 square becomes 3. So take 3 outside of this radical sign. Then we have 5 times 5, so take 5 outside, and then we have 2 times 2, so take 2 outside, and we're left with under root 2 only. Why am I doing this? Because recall that under root 25 is actually 5. Why is that? Because this is 5 times 5. So then we write 5 ones in the answer. So okay, so we're left with this. So we get 5 times 2, 10, and 10 times 2 is 30. So we get 30 under root 2. This is the answer. And I think I need to fix this in the marking scheme. Okay, and then question 6, we have to write under root 9000 in this form. So we have 2 cube times 3 square times 5 cube. So again, let's write it in this form, 2 times 2 times 2 times 3 times 3 times 5 times 5 times 5. So take the pairs outside. So 2 it comes outside of the radical sign, this 2 stays because it doesn't have a pair with it, then 3 goes outside, and then these two 5 go outside, and inside we're left with 2 times 5, which is 10, and outside we have 5 times 2 is 10, 10 times 2 is 30, 30 under root 10. So these two are the answers for question 5 and question 6. This needs to be fixed by me in the marking scheme or in the answers. Okay, next we need to know how to find LCM and HCF. So there are multiple methods discussed by different teachers. So usually I do it with my class using the factorization method. Okay, so let's see question number 1, which says find the highest common factor of 90 and 48. So I'll write 90 and 48, and then I'm looking for a common number that would divide both of these. So the smallest number is 2, so 2 45 here, 2 45s are 90 and 2 24s are 48. And that now again I'm looking for a common number that divides both of these, so that would be 3. Yes, because this becomes 9, and the sum becomes 9, and 9 is divisible by 3, and here the sum becomes 6, and it is also divisible by 3. So these numbers are divisible by 3. 3 1s are, and then 15, and then 3 8s are. Now looking for common numbers that would divide both of these. No such numbers exist, so our answer is simply 2 times 3, which is 6. Okay, let's do another one. Let's do question 4. Okay, so question 4. In question 4 we're given 3 numbers whose HCF highest common factor we need to find. So all these numbers are divisible by 3. So let's start with 3. 3 12s are, 3 21s are, and 3 3s are 9, and then 1 goes to 8 and it becomes 18, and 3 6 are 18. Again all of these are divisible by 3. So 3 4s are, 3 7s are, 3 12s are. And next we can't find any number that divides 4 7 and 12 together, so the answer is 3 times 3, which is 9. Okay, let's do a few questions on LCM now. Question 5, let's start with that. 20 and 24. So 2 is the common number that divides both of these, the smallest common number, so that this makes 10 and this makes 12, and then 2 again, so this makes 5 and this makes 6. And now for LCM we don't stop till we get 1 and 1 here, so just use 5. 5 will only divide this 5 by 1, and 6 stays untouched, and then write 6 again. 1 stays the same, and 6 divided by 6 is 1. So we got 1 1 in the end, so now we'll multiply all of these to get the LCM. So 2 times 2 times 5 times 6, this becomes 10, this becomes 12, so 12 into 10 is 120. Okay, now let's do the last one, question 9. So we have 48, then we have 72, and then we have 108. Okay, so 2 is the smallest common number that would divide all of these. So 24 over here, 36 over here, and 54 over here. Again all these will get divided by 2, 12, 18 and 27. Okay, now 3 divides all of these together, so 3 4s are 12, 3 6s are 18, and 3 9s are 27. Next, we don't have a single number that divides all of these together, so let's just use 3. 3 will divide 6 by 2, and 3 3s are 9. And let's write 4 as it is. Now let's use 2. 2 will change this into 2, this into 1, this to 3. Then use 2 again. We'll get 1 over here. 1 stays the same, 3. And then use 3 over here. And we'll get 1, 1, 1. So now multiply all of these together. So multiply these numbers together. 2 times 2 times 3 times 3 times 2 times 2 times 3, and we'll get 432, which is the answer, which is the lowest common multiple of these three. Okay, next we have again question number 1, where we have to find in fact we have to write 30 as product of prime factors. So simply start dividing 30. Start with 2, 15s are 30, 3 5s are 15, and 5 1s are 5. So 30 in the form of prime factors is 2 times 3 times 5. For part B, we have to find the lowest common multiple of 30 and 45. Now there are two ways of doing it. One is that you write 30 and 45 together and find its LCM. We start with let's start with 5, and 5 6 are 30, and 5 9s are 45, and then use 3 2s are, and 3 3s are. Next we'll have to use 2, this will become 1, this will stay 3, and then again use 3, and this will become 1, and this will become 1 as well. So the LCM is 5 times 3 times 2 times 3. 5 times 2 is 10, 3 times 3 is 9, so 9 times 10 is 90. So answer for part B is 90. Now there's another way of doing it, which is that we already have prime factor for 30. So we can find prime factors of 45 first. So 45, let's start with 5. 5 9s are, then 3 3s are, and 3 1s are. So the prime factors of 45 are 3 square times 5. Now we'll write these together. We have 30 in the form of prime factors, which is 2 times 3 times 5. Then we have 45 in the form of prime factors, which is, let's write 3 underneath 3, 3 times 5. Now we have to find LCM of these two numbers. LCM is the lowest common multiple. It says lowest, so remember the opposite of lowest is highest. Now we're choosing highest of these two values. We have 2, and then we have no number underneath it, so the highest number is 2. Then we have 3, and then 3 square, so the highest of these two numbers is 3 square. And then we have 5 and 5, so the highest of these two numbers is 5. So the answer is 9 times 2, which is 90. So this is another way of finding LCM using prime factors. Okay, question number 2 now, which is write 90 as product of its prime factors. So again, let's start dividing 90 with the prime number. So let's start with 5. 5 1s are, and 4 gets carried, 40 and 18. So 5 18s are 90, and then I'll use 3. 3 6 are, and then 3 2s are, and 2 ones are. So the prime factors of 90 are 2 times 3 square times 5. Okay. Next we have to find the lowest common multiple of 90 and 105. So one way is again using 90 and 105 like this and start factorizing these. We're looking for a common number, common prime number that divides both of these. So let's start with 5 18s are and 5 21s are. Then 3 would divide these two. So 3 6 are and 3 7s are. Next we don't have a single number that divides these together, so let's use 6 here and we get 1 here and 7 stays, and then again use 7 here and we get 1 and 1. So the LCM would be 5 times 3 times 6 times 7. So what does that give us? 5 times 3 times 6 times 7, which is 630. So the LCM is 630, which is the answer here as well. Alright, so we've learned another method as well in the last part in 1B, so let's use that method as well. Now I can find the LCM by finding the prime factors for 105 first. So let's find prime factors for 105. So that would be, let's start with 5. So 21s are, then let's use 7 3s are and 3 1s are. So prime factors for 105 are 5 7 and 3. So I'll write 90 here, 2 times 3 square times 5, and then I'm using 105 here, which is 3 5, and we also have a 7 over here. Okay, so again for LCM stands for lowest common multiple, opposite of lowest is highest. This is one way of remembering it. So of these two values, which one is highest? 2 and no 2. 2 is highest. Then we have 3 square and 3. 3 square is highest. Then we have 5 and 5. So 5 is the highest. Then we have 7 and no 7. So 7 is the highest. So the LCM is again 2 times 3 square times 5 times 7. 2 times 3 square times 5 times 7, which gives us 630. So same answer as before, but this time we've used the prime factors to find LCM. Okay, question 3 and 4 are pretty much the same, so we're not getting into that. Let's do question 5 now, because it has HCF, and I'm going to use the second method to find LCM and HCF, that is using the prime factors. Okay, so we're already given the prime factors for 48. In part A they're asking for the prime factors for 60, so I'll just use the answer given. We're doing question 5, so the prime factors are 2 square times 3 times 5. Okay, so I'm not going to do this again. Okay, part B, work out the highest common factor of 48 and 60. Now I'm not using the factorization method, we've already discussed that plenty. Let's use the factorization method. So we already know 48 equals 2 power 4 times 3, and we also know 60 equals, make sure to write 2 underneath 2, 3 underneath 3, and then 5 over here. Now we have to find, for part B, we have to find HCF. HCF stands for highest common factor. Opposite of highest is lowest. So which one of these two is the lowest? That is 2 square. Then of 3 and 3, 3 is the lowest, they're the same, so it doesn't matter. And then of 5 and no 5, no 5 is the lowest, so we don't write anything at all. So our HCF would be 4 times 3, which is 12. So remember, in HCF we choose the lowest power, and in LCM we choose the highest power. So of 2 power 4 and 2 square, 2 power 4 is the highest, and between 3 and 3 still 3 is the highest, and between no 5 and 5 is the highest. So the LCM is 2 power 4 times 3 times 5. Let's see what we get. 2 power 4 times 3 times 5, that gives us 240. Yes, it is the answer given over here. So 240. Again, let's do question 6 the same way. So we are given 72 as product of prime factors, so I'm going to write 2 cube times 3 square. Okay, and then the next part you have to find prime factors of 126. Again, I'm using the answer simply, that is 2 times, which is given over here, which is 2 times 3 times 3 times 7, so 2 times 3 square times 7. Okay, so next I have to find the HCF in part B. So HCF is the highest common factor, opposite of highest is lowest. Between 2 cube and 2, 2 is lowest. Between 3 square and 3 square, both are the same, so we write 3 square. And between no 7 and 7, uh, no 7 is the lowest. So the answer is simply 9 times 2, which is 18. Okay, and then for part C we have to find LCM. LCM is lowest common multiple, opposite of lowest is highest. So 2 cube gets selected, 3 square they're the same, so doesn't matter whichever 3 square you choose. And then between no 7 and 7, 7 is the highest. So 2 cube times 3 square times 7, 2 cube times 3 square times 7 gives us 504, which is also the answer written over here. Okay, so I've skipped many questions in between because they were pretty much the same as the previous question. And also they were taken from the GCE past papers, not from IGCSE. So question 12 after question number 6, I believe, is from IGCSE past papers as well. So let's just do this and then move to the word problems. Okay, so question 12, an integer x is written as product of prime factors as a square times 7b plus 2, and in integer y written as product of its prime factors is a cube times 7 square. The highest common factor of these two numbers is 1225, and the LCM of these two numbers is 42875. Find x and y. Okay, find the value of x and the value of y. Alright, so what we'll do first is write the HCF and LCM in the form of prime factors. So let's first factorize 1, 2, 2, 5. So we need to start with the prime number. Let's start with 5. So I'm just going to use my calculator. 1225 divided by 5 is 245. Again, this is divisible by 5. Divided by 5, we get 49, which gets divided by 7. 7 sevens are 49, and then 7 ones are. Okay, so x can be written as 5 square times 7. Sorry, the HCF can be written as 5 square times 7 square. Alright, next we need to factorize the LCM, which is 42875. Now let's start dividing it with 5 as well. 42875 divided by 5 gives us 8575. Again, this gets divided by 5, which gives us 1715. Again, it gets divided by 5, which gives us 343, which is divisible by 7. That was just a guess, but it worked. 49, and then 7 sevens are, and then again 7 ones are. So the LCM in the form of prime factors is 5 cube times 7 cube. Alright, so now I know that we have a number x, which is a square times 7b plus 2. Then we have a number y, which is a cube times 7 square. And then we have their LCM and HCF. HCF is 5 square times 7 square, and then LCM is 5 cube times 7 cube. So just by comparison we can tell that this A and this A should be these 5, right? So A is simply 5. Now B is some power of 7. We already have 7 square here, and this is 7 square. So this B plus 2 would be equals to this 3 here. So B plus 2 equals 3, which means B equals 1. So now we need to find the value of x and y. So x is a square times b plus 2. So x is a came out to be 5. 5 square times 7. B was 1, and b 1 plus 2 is 3. So let's see what do we get. 5 square times 7 cube, which is 8575. So we're getting this answer here. And excuse me, for y we know y equals this was a cube times 7 square. Yes, so a is 5, so 5 cube times 7 square. Let's see what do we get. 5 cube times 7 square is 6125. So we're getting the correct answers. So what we did was we simply wrote the LCM and HCF in the form of prime factors, then we wrote it in this form and did the comparison to get the values of A and B, and then we substituted those values here and here to get the values of x and y. Now we're doing some word problems related to HCF and LCM. So most of these questions are again from either from GC past papers or from different books, but I think they're pretty good practice questions because this topic is in our syllabus as well, so we never know how the examiner might ask it. Okay, so 1A, find LCM of 12, 30 and 66. So let's start with 3, and we can also start with 2. 2 6s are, 2 15s are, 2 33s are. Now let's divide with 3. 2s are, 5s are, 11s are. So next use 2, this becomes 1, these stay unchanged. Then use 5, these both become 1, this stays unchanged. Then use 11 and we get 1 1 1. So now the LCM would be the product of all these numbers. So 2 times 3 times 2 times 5 times 11, which gives us 660. Okay, part B. Let's do B here. Okay. I'm wondering why have I written seconds here in the answer. It should just be 660. Okay. Part B, 3 light ships flash simultaneously at 6 a.m. The first light ship flashes every 12 seconds. the second every 30 seconds, and the third every 66 seconds. At what time will the three light ships next flash together? So this is either an LCM question or an HCF question. How do you distinguish between the two? Should the next answer be bigger than these numbers or smaller than these numbers? Next time when these three light ships will flash simultaneously, it will be a bigger number than 66. So it's a question of multiple, lowest common multiple, and not a question of factor, because factor of these would be these three numbers would actually be a smaller number, a common factor. So this tells us that this question is related to the lowest common multiple. So we've already find the LCM of these three numbers they've talking about. So the LCM was 660. So 660 seconds need to be added to 6 a.m. 6 a.m. plus 660 seconds. 660 seconds divided with 60, and we will get 11 minutes. So add 11 minutes to 6 a.m. and we get 6:11 a.m. Question number 2. Okay. Green line buses run every 10 minutes, red line buses run every 20 minutes, and purple line buses run every 35 minutes. One bus from each line leave the city center at 0900. After how many minutes will the buses from the three lines next leave the city center at the same time? So the answer would be bigger than these three numbers. So that means this is a question of multiple, lowest common multiple. So we have to find LCM of 10, 20 and 35. Let's start dividing with 5 first. So 5 2s are, 5 4s are, and 5 7s are. And then let's divide with 2. 1s are, 2s are, 7s are. Then we'll divide with 2. So 1 1 7, and then we'll divide with 7. So we get 1 1 1. So LCM is 5 times 2 times 2 times 7, which gives us 140 minutes. So after 140 minutes, the three buses will again leave the city center together. This is some extra information given in the question which is not needed. If the question was at what time will the three buses next leave the city center, then we would have to add 140 minutes to this time, 0900. That would give us, I believe, 11:20 or whatever the answer is. But right now we don't need to use 0900. Alright. Okay, question 3. Which is, three lighthouses flash their lights every 20, 30 and 50 seconds respectively. Given that they flash together at 8 p.m., when will they flash together next? Again, this is a question of multiple, lowest common multiple. So 20, 30, 50. Let's find a common number that divides these three. Let's use 10. So we'll get 2 here, 3 here, 5 here. Then let's use 2. This will become 1. 3, 5 will stay unchanged. Next we'll use 3, 1, 1, 5. And then we'll use 5, which will make this 1, 1, 1. So the LCM would be 10 times 2 times 5 times 3. So this becomes, I believe, 20 times 15 is 300. Yes, 300. So 300 minutes. 300 seconds. Now add 300 seconds to 8 p.m. plus 300 seconds. So 300 seconds is how many minutes? 300 divided by 60 is actually 5. So add 5 to 8 p.m. So 8 p.m. plus 5 minutes would simply give us 8:05 p.m. Okay, so let's quickly go over question number 4. 3 bells toll at interval 8, 15 and 24 minutes. If they toll together at 3 p.m. at what time will they toll again? So first you'll have to find LCM of 8, 15 and 24. You'll get certain minutes that you'll add to 3. I believe you will get 120 as the answer for 4 first part, 120 minutes, which is 2 hours. So 3 plus 2 hours will give us 5 p.m. Okay, this would be question 4. And similarly in question 5, David was trying to sleep one night, but there was too much noise around him. His clock ticked every 5 seconds, then a tap was dripping every 7 seconds, and his pet dog snored every 12 seconds. He noticed on his clock that all three events happened together at the stroke of midnight. After how many seconds will all these three events happen together again? So that is your cue. The word again means that it is a lowest common multiple question, because when will these three happen again? It will be a number bigger than 5, 7 and 12. So it's a question on multiple. Alright, then you'll find multiple of 5, 7 and 12 for part A, and you will get 420. I'm directly just reading this answer. And then for part B, how many times will this happen together between midnight and 1 o'clock? So this is 420 seconds. Now how many times 420 second will occur in 1 hour? So 1 hour is 60 minutes, and 60 minutes is 60 times 60, which is 60 times 60 is 3600. So 3600 divided by 420 gives us 8.5714. So this event can't happen 8.5 times. It can happen either 8 times and 9 times, but we don't have enough duration for it to happen 9 times. So the answer is 8 simply. Okay. Okay, that was question 5. Okay, so question number 6 is, Sam has 39 pencils, 39 pencils and 26 pens to distribute to his classmates. Each student must receive the same amount of pen and pencil, and there will be no pens or pencils left. Part A, what is the greatest number of students in that class? So greatest is your cue in this question. Greatest means highest common factor. So this question is related to HCF. So you find HCF of 39 and 26. Let's divide it with 13 because that's the only possibility. 13 3s are, and then 13 2s are. Then we don't have any number that divides both 3 and 2 together. Since we're finding HCF, we stop here, and the HCF is simply 13, which is the answer over here. So we have maximum 13 students in the class. How many pencils and pens will each receive? So there are 39 pencils and 13 students. So we get 3 pencils each, and there are 26 pens to be divided between 13 students. So each get 2 pens. So 3 pencils and 2 pens. Okay. Question number 7. Okay. So a rectangular field measures 450 by 306 meters. The whole field is divided into identical square plots with no land remaining. Find the largest possible side length for the square. Largest means greatest or highest, and highest common factor. So this is also a question for HCF, and we find HCF for 450 and 306. So let's divide with 3. So 450 divided by 3 is 150, and this becomes 102. Now let's divide this with 3 again. 150 divided by 3 is 50, and this is 102 divided by 3 is 34. Now let's divide this with 2. So this becomes 25 and this becomes 17. Okay, and now we don't have a single number that divides these two numbers, 25 and 70. So LCM will be, HCF will be product of these. 3 times 3 times 2, which is 9 times 2, which is 18. Okay, question number 8, the final question of the worksheet, thankfully. And this is a question from IGCSE past papers, and that means it's an important question. And another thing, it contains questions from different topics, so you should be able to do this question if you're done with your grade 8, or it's grade 9 in some of the schools, which means you should be done with the first year of IGCSE. So if you're younger than that, I would suggest leave this question for now if you haven't studied average speeds yet. Alright, so part A is calculate the speed of car A, give your answer in kilometer per hour. So the formula for speed is equals to distance over time. So the distance is 7.6 kilometers, and the time is car A takes 2 minutes and 40 seconds. Okay, and we have to give the answer in kilometer per hour. So 2 minutes and 40 seconds need to be converted into hour. So let's first change this into seconds. 2 minutes is 60 plus 60 and then plus 40. This makes 160 seconds. Divided with 60 and again with 60 to get hours. So divided by 3600, I am getting 0.044444. So 0.04, and I can put a small dot on 4 to show that this 4 is recurring. Now in my calculator, I'll do 7.6 divided by answer, and I'll get 171 kilometer per hour. Answer for part A. Part B is both cars start the race from the same position S at the same time. Find the time taken when both car A and B are next at the position S at the same time. This next is your cue that this is a question on multiple. So we have to find lowest common multiple for 240 and 2 minutes 40 seconds and 2 minutes 25 seconds. So to find LCM, let's first change 2 minutes 40 seconds into seconds. So this would be 60 plus 60 plus 40, which is 160 seconds. And then 2 minutes 25 seconds is 60 plus 60 plus 25, which is 145 seconds. Next, we will be finding the LCM of 160 and 145. I'm honestly not going to do this. You'll do this yourself and you'll notice that you get 4640. 4640. Now these were seconds, so we're getting 4640 seconds, but we have to give our answer in minutes and seconds. So 4640, divide this with 60. 4640 divided by 60, I'm getting 77.333. This is in minutes. and I need to give answer in minutes as well as seconds. So one way of doing that is, this is 77 whole minutes and then some 0.333333 minutes. So one way of doing it is, in your calculator you will find this key which has a circle and then 3 commas. When you press it, you will simply get the answer in minutes and seconds. So you're getting it is showing me 77 seconds and 20 minutes. Another way of doing it is, we got 77 whole minutes, so we get 77 minutes, then you have 77.33333 flashing in your calculator. You'll subtract 77 from it and we get 0.33333 minutes. So to change this into seconds, simply multiply this with 60 and you'll get 19.99999, which rounded off gives 20 seconds. So we're getting 77 minutes and 20 seconds. Okay, B2. Find the distance that car A has traveled at this time. Distance is speed into time. We already know speed from part A, which was 171 kilometer per hour. Now the time needs to be in hour as well. So the time in part 1 came out to be 4640 seconds. 4640 has to be changed into hours, so divided with 3600. So 177 into this fraction gives us 220.4 kilometers. Okay, we're done with this worksheet. I'll see you next time.